Welcome to Ask and Learn.
Hello and welcome to this video solution of numerator. So here we are given that there is a 150-pound skier at the point A and he has a speed of 5 feet per second, right? Now you have to determine his speed when he reaches the point B on the smooth slope. The equation of this slope is given to be y, that is equal to 50 cos of uh, pi x by 100, right? And you have to calculate the normal force on the skier at the B and his rate of increase in speed, right? So this is pretty simple. So first of all, what we have is this is the trajectory we'll be having sort of like this, right? This is the point A at the topmost section, and here you've got point B, which is 35 feet, right? Now let's start at x equal to A, which is x A that's equal to 0 feet, right? And x B is 35 feet. This is measured along the positive direction, right? Positive x direction. Okay, so what you can do is yeah, you have to calculate the value of y. So ya will be equal to, if you plug in it here, it's 50 cos of pi 0 over 100. So it's pi times 0. So it's 50 feet, right? Whereas yb, if you plug in the same 50 cos of pi times 35 by 100, uh, 30, yeah, that's 22.7 feet, right? So you have got both ya and yb. Now you have to apply the principle of conservation of energy. So that means you have got the kinetic energy at A plus potential energy at A, that's equal to kinetic energy at B, right? Assuming that assuming the height from B itself, right? This potential energy is calculated from B. So A B I'm taken, right? Okay, this is half m V square plus mg. Uh, let's say here you take y a minus yb half mv square, right? Mass is you have got 150 over 32.2, the value of g itself, right? You have to take mass. This is 5 square, that's given, right? Plus this is second 150 over, here only you have got 150, right? Mg is 150 times the difference of height is 35, right? Oh, sorry. uh, this is 22.2 minus 50, or maybe 50 minus 22.2, right? That is equal to half times this second 150 over 132.2 VB square. So VB from here will be around 42.2 feet per second. This is the velocity at B. Next, you have to take the expression for radius of curvature, rho, which is given by 1 plus dy dx squared to the power of 3 by 2 over d2y over dx square, right? So what you can do is you need to just take the derivative and of this equation, and you have to plug in the value of x to be 35, right? Feet here. So this gives you dy dx. You can do it yourself, and this will be minus 1.399, and d2y dx square, that's equal to minus 0.0224, right? So this gives you the radius of curvature rho to be equal to, if you just evaluate, then it's 227.024 feet, right? This will be the radius of curvature. Now to calculate the normal force, you need to find this angle theta, which is equal to tan inverse of dy dx, right? So this is tan inverse of minus 1.399, and this comes out to be around minus 54.44 degrees, right? So this is theta. Now if you just write down the forces, minus n plus 150 of this angle of 54.44, that's equal to m v square by r. Rho is the radius of curvature, na? And this is minus n plus 150 cos of 54.44, that is equal to, the mass is 150, 32.2, v is 42.2 squared over 227, right? And 024. So just draw a simple diagram for this. Let's say this is the Skya. This is a normal reaction acting, right? And this is the weight mg, and this component is uh, mg cos theta. This is angle theta, right? So that's what we have done here, and from here the normal reaction will come out to be 50.69. Around 50.69 Newton, right? It's converted from pounds. I hope this is clear to you, and have a very good rest of the day. Thank you.